Hi, I'm Ginger Desmond with Stantec, and this is a presentation on um, how to, if you're used to building offices or other developments, how you can change your thinking to um, work with laboratory building design. So, a little bit about Stantec. We are a global company. We have offices all over the US. We are number 5 in laboratory design, and we've got clients and research facilities all over the country and, in fact, all over the world. Safety is a very important thing at Stantec, and it's also very important in laboratories. So when you are working in or around a laboratory, even as a non-technical person, if you're in construction or if you are an architect or if you are a builder, you need to be aware of what the hazards present could possibly be. There are all kinds of chemical hazards, biohazards, and you need to follow the safety protocols in place for that laboratory and follow what you are instructed to do within that space. So our agenda for today is looking at the market in general, what the trends are in laboratory design, and if you are looking to convert a building from an office or another kind of facility to a laboratory, what sorts of things you need to look out for, and then for some of our projects, what the challenges and lessons learned have been. So the overview and trends. So what is driving all of this science right now? There's a number of different things that are driving the science, and they tend to be very small. So sequencing DNA, sequencing proteins, sequencing the structure of a number of different things have driven a lot of innovation within science and a lot of new opportunities that those can present. And one of the big examples of that is our COVID vaccines with the mRNA vaccines. Um, these technologies are also being used in a number of other different therapies listed on the side there that you can see. And also in the field of energy and physics. There's a lot of advances with small technologies, nanotechnologies, thin films on things that are advancing those fields as well. So there's a lot of innovation happening right now. And the commercial users really span a wide array of different fields. And in pharma and biotechnology, these can be anywhere from drug development to new therapies. In engineering, it is all over, and they're very cross-disciplinary as well. So, you know, it can be bioengineering for medical devices or medical therapies, and it can also be for energy storage, and then also in data technology. So there's a variety of different needs out there, and they all have slightly different things, but they also all have things in common. So if you think about the development of science and technology, it's really a pipeline. So you have people coming out of universities, hospitals, other think tanks, anywhere that you have ideas developing, and those ideas spin off into startup companies. Those startup companies have very specific needs. So if you're looking at a market that may be just starting out, you need to think about the types of clients that you might have, or the types of tenants that you might have in your space, because they have slightly different needs than something that may be a slightly larger, more established firm, but maybe not quite, you know, multinational or huge like you know, a big drug firm. But they're still looking for some things like how they're going to retain their employees, what kind of amenities they're going to have. They start to think a little bit more about the amenities that they may want for their employees, and how they're going to keep people on their campus. And then as they start to grow a little bit more, how they expand, where are they expanding to? Maybe they're ready to start manufacturing, where their manufacturing facility is going to be. And then of course you have large established firms where they need to really think about the connectivity of those different campuses and people. So in Boston, it's a very established market. We've been working in science and technology for a very long time. And some of the big drivers of those are pretty obvious, MIT, Harvard, but there's also Boston University, Northeastern, Tufts, other institutions in the area that have very strong science and technology graduates. Longwood Medical is also a generator. There's a cluster of hospitals that generate a lot of medical research, and you can see that the green spots around those are the science and technology areas where those where the companies tend to cluster. Some of them are emerging and some of them are very well established. And as things fill up, it gets pushed further west, it gets pushed further north and south, but generally along modes of transportation, either public transportation or along the major highways. So the clusters across the US, the established clusters are, of course, down the East Coast and down the West Coast, where there are some major universities and other think tank developments. And then in Chicago, in the center of the country, and there's a number of other clusters that are emerging right now. Texas is very strong in a number of different cities, and then a number of other places, sort of in the Midwest, and then also a little bit in Florida as well. So what are the trends that you think about when you think about laboratory planning? So modularity, flexibility, and openness. We talked a little bit about how there are a number of different studies and areas of research that you might be thinking about having as tenants, and how those people work is slightly different. So the more you can leave those spaces flexible and open, the better off you'll be. Modular thinking comes into things like cold rooms, clean rooms, other spaces that are specialized, that where you might have a prefabricated modular unit that comes in and may be able to expand. Open planning has been a concept that is employed in laboratory design, where you can have flexible modular furniture that is movable and sort of plugs in and in various configurations, so that you have services, which you can see on the right-hand slide, that come down from the ceiling, and you can really use those in a much more flexible way than fixed furniture or fixed walls. So on top of everything that you need to think about for a laboratory, there are people in the laboratory, and they're going to want all of the same kinds of amenities that you would have in any other office space. They want access to light, air, outside if possible, all the collaborative spaces, all of the kind of kitchen amenities and open office areas that other office tenants may have. So thinking about conversions, your thought process when you're looking at this is really no different than any other development. You're going to be looking at the market drivers, the goals of your particular project, and the site conditions, and that's going to give you a set of criteria for developing your project. But because you're going to be layering in all of the needs for a laboratory, you need to really keep it kind of simple and organized. So you'll want to, in whatever kind of checklist that you already use when you're thinking about a new project, you just need to expand that to include some of the things for laboratories. So structural, the architectural environment and MEP systems that exist, how can those be converted if they need to be converted or replaced? Is it really a suitable building for a laboratory? And laboratories, as you probably know, are very different from an office building in that they use much more energy. They have exhaust needs. The air in a laboratory is once through, so you can't recirculate that air once it's gone through the laboratory. You need to recover the heat and then exhaust the rest of the air. The equipment is very specialized, often very sensitive to vibration, to temperature, to humidity. And because of those things, and then because of the experiments that people are running, scientists need to be able to access the building 24/7, 365. So they really need to be able to check, monitor, and control what's going on in their spaces. So, and then related to that, they will have backup power for a lot of equipment, so that it doesn't go down in the event of an emergency, and that is separate from your life safety needs. And we talked about the ones through air. So when you're looking at converting a building, you need to start looking at all the different systems, and whether or not you have the capacity either on the site, available within city infrastructure, or can you upgrade it? So natural gas is a big issue. A lot of communities are pushing back on fossil fuel use. So is it available? Can you use it? Often it is it's limited on site, or you need to think about your emergency backup generators. How are you going to fuel those? That's usually the pinch point for going either all electric, which is very difficult in a laboratory building, or going carbon neutral. HVAC, you're going to need a lot more air, obviously, and if it's going once through a building. But you need to look at what kind of shaft space you have in an existing building. Is it flexible enough to accommodate that additional air? Do you need to make some major structural changes to accommodate those larger shafts and larger equipment on the roof or at grade? Water, if you're thinking about a laboratory building and you're thinking in the life sciences or chemistry, you're probably going to need some purified water. So you need the site capacity, and you need to be able to control the effluent from that, and you need to understand the city requirements or municipal requirements for that effluent treatment. Electrical, again, the usage is much higher than a typical office or other use. So you need to look at the site capacity and the utility service, or what capacity you may have on site to generate some of that. And for structural, you've got to look at the building's infrastructure for vibration control and capacity. Office buildings tend to be much lighter, and accepting a more bounce to the floor than you can have with a laboratory building. So all of this adds up to a much larger penthouse, much more infrastructure in the building, whether you're providing it as a developer or whether you're just accommodating it for the tenant fit out. You need to think in terms of the space that you need to have for that. Chemical safety is definitely something that is specific to laboratory buildings and not found in other types of buildings. Within any given building, code will restrict the amount of any category of chemicals. Flammables are a typical one in a laboratory, that you can have on any given floor. So on this diagram illustrates the way the IBC breaks that down. On floor 1, you can have 4 control areas, that is fire separated areas, with a 2-hour floor and 1-hour walls up to level 4, and it becomes a 2-hour rating above that. So those areas are separated from each other, and that allows you to have that represented amount of chemicals stored on that floor. So 1, you can obviously have the most amount of chemicals. 2, you're restricted to 75% across 3 control areas, and then it goes up from there until you get up to floor 9, where you're restricted to 5%, or sorry, at floor 7, you're restricted to 5%, but above floor 9, you're restricted to 5% and only 1 control area. So it becomes very restrictive of what you can do above those floors. Below grade as well, it follows the same logic, and you can have nothing below floor 2. Below grade. And that affects what kind of science you can do in the building. So chemistry obviously is very limited by this. You're really limited to the first 3 floors without any other interventions. Biology, where most of the life sciences would fall, plus or minus, you can pretty much go up to floor 9 without really running into restrictions. Floor 7, 8, and 9, you may have some restrictions on what you can do, and you may need to do some other interventions. So some of the things you can do are look at H occupancies, either as an accessory occupancy to a regular B occupancy, which you would have for your office building and which you have for a laboratory. You can have an accessory H occupancy as part of that construction, but that is going to add some cost and some other considerations for fire protection to your building. An entirely H occupancy building is extremely expensive and would probably just be a sort of custom build that you would need to address. But that it does allow you ways to increase your chemical use on higher floors. And I would note actually on the discussion of chemical storage, California code does accommodate chemical use on upper floors, and it will be interesting to see if that is a code that is adapted to other parts of the country. So how do you deal with all of this? This is really a chart to show the complexity of thinking about who needs what, and really it's very hard to tell. You can't just have a one size fits all. You need to really tune it to what you're thinking about for specific uses, and you can see that there's a wide variety of needs and options across all the different sub areas of research, even within something. I used this example. This is a biological engineering department at a major university. And even within that category of biological engineering, within the sub areas of research, there's different levels of hazard. So you really need to think about maximizing the flexibility in the base building so that you can accommodate different levels of that hazard. Loading docks are another area of the building that are impacted by scientific use. Like everything else, the deliveries there's a lot more deliveries. There's different kinds of things. In the upper left-hand picture, you can see some gas dewars. There's a lot of gases that will either come in cylinders like this, or in larger containers dewars, or will need to be accommodated by a bulk or a mini bulk system on site. You've probably seen those at hospitals. It's a large tank, either vertical or horizontal, typically has a regulator next to it. The pad is fairly large, and there's some conversion that goes on. They look a little scary, but they're for the most part inert. But it is space that you need to accommodate and think about in terms of code acceptance. Biohazard and other waste that may be going out of the building is another thing that can affect some loading dock planning. So there's just a little bit more space that you need to have inside the loading dock, and then also outside the loading dock to accommodate some additional trucks. Everything in the lab is really dictated by safety, and the layout of the spacing between the benches is part of that. So a typical lab module is based around the size of the bench. So a typical mobile bench top will be either 5 or 6 feet long, and they're almost always 30 inches deep. So those are configured into islands or along that perimeter of the building, and they dictate that module of 10'6" to 12 feet so that you can have the safe, clear distance between those benches or areas for floor equipment or tabletop use, as illustrated in this diagram here. So that bench, island bench, is typically somewhere on the order of 15 feet plus long, and then that will determine your module in the long dimension. So your building wants to be in dimensions that will accommodate this safely. So typically somewhere around 22 feet up to 35 feet. And then the depth of that can be, as deep as you can get it, with keeping in mind the vibration control that you need. So it's always a balance of accommodating the lab as openly as possible and controlling the vibration. This, I should note, is sort of a biology-oriented diagram here. In biopharma, you're going to have a number of rooms that are enclosed as well, or may want to be enclosed or segregated from the rest of the open lab. And these will have specialized equipment, equipment that needs to control light or air movement in a more controlled way than the rest of the laboratory, or it contains exhaust devices. It contains cell culture rooms, so biosafety cabinets and incubators that need to be segregated from the rest of the lab. So anything that really needs to have its own controlled environment will be in another zone of the laboratory. And that obviously generates a building that is very, rigid is not the right word, but labs like rectangles. So labs like rectangles, and they like them to be as regular as possible. So the more regular you have, at least in a laboratory zone, the more accommodating that will be to the flexibility of the laboratory. Sustainability is another feature. We talked a little bit about that in terms of what you might be running into as far as carbon use in the building. It is difficult to make a sustainable lab, but it's not impossible. And there's a lot of technologies out there that can help us with that. You know, some of the typical examples that you probably use everywhere are, you know, ground source heating and solar panels. Solar is a little bit tough, only because your rooftop is so full of mechanical equipment. It is difficult to incorporate solar panels on the roof of a building, but if you have site opportunities for that, that's a different way to look at it. Active chilled beams and DOAS systems for your HVAC are often employed in a laboratory to just reduce the quantity of air that's moving through. So you limit the air movement to the safe levels for the lab, and then control the heat and cooling through chilled beams. And then energy recovery, the more advanced systems you can have can recover a lot more energy. And there's things like Smart Stack, which can control the exhaust in a much more efficient manner. So there's ways to address it, whether you do it or whether you have your tenants address it. So some of the things that we've learned with the rush to have everyone build laboratories, we've seen pretty much, I don't want to say every way, but we've seen a lot of different ways that people approach this. What you're looking at here is a mid-construction change of use in a building. The building started out as an office tower, and midway through, the owner decided they wanted to go to, actually more than midway through, because the building had construction documents and was about to start construction. They wanted to change the use to more laboratory. So the impact of that, the structure was already set up for laboratories because it did have some labs on the lower floors, but the increase meant they needed to increase the penthouse space and the mechanical systems for the building. So it's a little bit of a confusing diagram, but what you're looking at is the gray, which was the original space that had been set aside for MEP systems, and then so that's the lower penthouse, and then the added space on the right for the potential specialized equipment. And then on the rooftop, the gray represents what did not change in the base planning, and the pink is what did change. The yellow is kind of reserved for either future use or distribution over to the equipment. So the entire, you can see the upper penthouse, the entire space is now full. Previously, it was about 2/3 full of the equipment. The shaft space is also grew proportionally down below. Conversion. So this was a project that did not go ahead, but we were looking at converting an existing office tower from the 70s to office use. So they looked at converting floors 1 through 6 and then decided, because it worked relatively easily, which I'll explain in a minute, they decided they wanted to carry that conversion up to floor 15. So what they were doing is, because this building had gone to an elevator on demand system, they did have excess elevator capacity, and that was the way that we could address the additional shaft space for this building. We were taking over some of those elevator shafts for the exhaust, the new exhaust risers. Without that, it would have been very difficult to do because this was a post-tensioned concrete building. So I'm not sure we would have been able to do it other than taking over those elevator shafts. Or, you know, anything's possible, but it would have been very difficult. And then we were accommodating the air handlers out on a low roof section. And then on the upper floors, there was a individual room for each one of those floors. The exhaust on this roof would have been pretty extensive. Fortunately, you know, as an office building, it had a relatively open rooftop, but you can see the orange with the exhaust fans. It would have been very full when we were done with it. The other issue is, of course, that it was a office building, so the floor to floor was 12 feet. With, you know, 5 times more air moving through the building, we had to be very careful about how we would distribute the air. So this diagram illustrates, this drawing illustrates the tightness of that. The low part of the ceiling is where the ductwork would run, and the only way we could accommodate that as well was to cut into some of the beams. So we would have been creating notches in that beam for the distribution to come through the lab. And this last one is a conversion. So this is a straight up conversion. It was thought about as a conversion. They looked at doing some manufacture. This is clearly a warehouse building, but they looked at doing this as a manufacturing building, but the infrastructure of the warehouse building couldn't quite accommodate that. So what they've ended up doing is positioning this as a 1- and 2-story. One building is 1 story, the other building is 2 stories, laboratory space, and they've had some interest generated on that. This is under construction now. And they're introducing, you know, a spot for food trucks and other things to make it an exciting and interesting place. This is going to be part of a larger development. So this is thought of as a temporary or semi 20-year, 30-year temporary use until the rest of the development comes along. So that is all I have today. If you have any questions, I'd be happy to answer them. And if you need to contact me, I'm happy to answer anything via email as well. Thank you.